Welcome to Haskell Field School. Today, we are looking at curing and protecting concrete. Curing is an essential stage in concrete construction, serving as the final step. Once that concrete's been all mixed up, put in its proper spot, made nice and solid, and finished up just right for the specific application, it's time to start curing.
Our objectives for today are:
1. We need to be able to describe the concrete curing process and the primary factors in its progress. 2. Describe various approaches to curing concrete. Lastly, we need to be able to identify methods used to protect concrete during the curing process. The whole point of curing concrete is to keep it moist and at the right temperature. Curing is especially critical for slabs on grade because they have a large surface area compared to the total volume of concrete. As a result, evaporation from the surface can be so rapid that a slab will crack as it sets. You have to watch out for temperature differences too, because they can cause stress cracks on the face of the slab. So, curing involves taking all sorts of steps to make sure we don't lose too much water through evaporation and maintain an acceptable concrete temperature. It's worth noting that the American Concrete Institute has a bunch of publications that cover the curing process. One of their most thorough publications on the subject is the Guide to External Curing of Concrete. To grasp the ins and outs of the curing process, we have to start by digging into hydration. Hydration is the key to concrete settling and getting sturdy. It's all about that chemical reaction between the cement and water, and that's what makes the concrete harden and gain strength. Now, this reaction also creates some heat. Once the cement and water mix up, there's a little waiting period, about an hour or so before the chemical reaction really gets going. But here's the thing, we can tweak that wait time with admixtures to make it shorter or longer. The length of dormancy is also influenced by the temperature of the concrete and the local weather conditions. That little dormant period gives us a window to mix the concrete, haul it to the site, and get it all poured into forms before it starts settling. But once that cement wakes up from its nap and hydration kicks into high gear, things start changing. The concrete starts losing its ability to be shaped and maneuvered like we want it to. That plasticity and workability, well, they start fading away. The hydration process of that cement doesn't stop once we're done with the finishing. Oh no, it keeps on going and going. And let me tell you, the longer that cement keeps hydrating, the mightier it gets. Now, in the first 3 to 7 days, hydration happens quickly. But don't be fooled. It keeps on chugging along at a slower pace for as long as it needs to. When that cement in the mix starts hydrating, some magical things happen to our concrete. We're talking increased durability, better resistance to wear and tear, more strength, and improved water resistance. It's all because of that chemical reaction called hydration, which uses the water we mixed into the concrete in the first place. And here's the kicker. As long as there's moisture around, hydration keeps on going. That's where the curing process comes in. It's our way of making sure we don't lose that precious moisture and, if needed, add more to keep the hydration train rolling. How we handle that hydration, or what we call wet curing, makes a world of difference in the strength of our concrete. If we just let the concrete do its thing without any special care, we're looking at the weakest result possible. But check this out. If we give it 3 days of proper wet curing, followed by 7 days more, and then let it fully dry in the air, that's when we see some serious improvement in strength. We're talking a substantial difference here, folks. When we give that concrete a solid 7 days of wet curing, it's going to hit the same strength level in just 28 days that it would normally take a whopping 90 days to reach without wet curing. That concrete will keep getting stronger and stronger, even over a really long period of time, as long as we make sure there's enough moisture for that curing process to keep on rolling. Hydration isn't just about moisture, it's also about the temperature of our concrete. We want our concrete to be in the range of 40 to 80 degrees Fahrenheit for ideal results. When the temperature drops below 40 degrees Fahrenheit, our concrete takes its sweet time to gain strength. But when the temperature goes above 80 degrees Fahrenheit, things speed up, and that concrete gains strength faster. So remember, finding that temperature zone is key to getting that concrete to reach its full strength. Let's talk about temperature and its impact on curing. Whether it's scorching hot or freezing cold, both extremes can mess with our curing process. When we're dealing with hot weather, things can get tricky. It can lead to reduced strength, a shorter time for the concrete to set, and a real quick drying of the fresh concrete surfaces. It can even dry out unprotected concrete so fast that the surface starts settling before we even finish our work. So remember, in hot weather, we have to be extra careful and take the necessary steps to protect that concrete and keep our finishing game strong. Let's dive into the impact of hot weather on our concrete. When it gets hot out there, it heats up our concrete from the inside where all that hydration magic is happening. But if we cure that concrete in temperatures above 80 degrees Fahrenheit, it's going to have less strength. And if we go all the way up to 120 degrees Fahrenheit for the curing process, well, that concrete is going to end up with way less strength compared to when we cure it at a cooler 55 degrees Fahrenheit. So we have to aim for those cooler temperatures to ensure our concrete gets the strength it needs. Let's talk about the impact of cold weather on our concrete. When it gets chilly out there, it can really bring down the temperature of our concrete, and that's when things get a bit tricky. Hydration, which is the secret sauce that gives our concrete strength, almost comes to a halt in those cold temperatures. Our concrete takes a longer time to set and it gains strength at a snail's pace. And if we cure that concrete at a temperature below 40 degrees Fahrenheit, it's going to end up with a lower ultimate strength compared to if we had cured it within the desired temperature range. So when it's cold outside, we have to take extra measures to protect that concrete and make sure it gets the strength it needs to withstand the test of time. With curing procedures in place that are designed specifically for wild swings in temperature, we can protect our concrete. So remember that we have these procedures in our toolbox to keep our concrete in the perfect temperature range and ensure it becomes as strong as it can possibly be. Once we're done with the finishing touches, we have to jump right into the curing process without wasting any time. See, curing is just as crucial as finishing, especially when it comes to slabs. If we don't give it the proper attention and control, we're going to end up with a weak concrete surface. That surface will not be able to handle abrasion and it will wear out in no time. Not only that, it might even get discolored and it can start scaling or spalling. When we give our concrete a solid 7 days of curing, the surface ends up with twice the abrasion resistance compared to those cured for just 3 days. If we delay the start of curing by as little as 24 hours, we're looking at a whopping 65% reduction in abrasion resistance. Delaying the start of curing can also lead to cracks, crazing, and a complete breakdown of the surface's durability. So hit the ground running with that curing process to ensure we have a surface that can take a beating and remain strong for the long haul. There are potential risks involved with wet curing. If our concrete dries out and we try to re-wet it, we're setting ourselves up for some trouble. We're talking about crazing and scaling of the surface. So we have to be proactive and start the curing process as soon as possible. And once we start, we have to keep that surface nice and moist for a solid 3 days or even longer. That's how we prevent crazing and ensure we have a surface that's strong and durable without any unsightly scaling. So give that concrete the care it deserves during wet curing. We've got a bunch of methods you can use, and any one of them could be the right fit for a specific job. When selecting a method, you should take into account factors like the concrete's properties, the desired outcome, and any constraints we might have in terms of materials or equipment. Consider the characteristics of the concrete you're working with and think about the desired results you're aiming for, taking into account any limitations we might have in terms of materials or equipment. If we leave formwork in place during curing, it actually helps us out by reducing evaporation from the concrete. But here's the important part. We have to make sure to loosen those forms, wet the edges of the slab, and keep them nice and moist. The exposed surface needs to be wet enough that water runs down the inside of the loosened form. And to keep that surface wet, we've got a couple of options. We can cover it up with something like burlap, or we can do light sprinkling. Plastic is not suitable if we need the surface to look top-notch since it often causes stains. If we remove the forms before curing is fully complete, we have to make sure to cover the concrete, including the edges, We can use a wet covering or we can apply a membrane-forming curing compound. The key is to provide that protective layer to keep the curing process going smoothly. Fogging, sprinkling, and spraying all help with the curing process by keeping the surface moist. This way, the water inside the concrete that's needed for hydration isn't pulled up to the surface or edges, where it would just evaporate. You have to make sure the water reaches all the exposed surfaces often enough to keep the concrete continuously damp. When dealing with flat surfaces, we use a misting nozzle, while soaker hoses are often used for vertical or sloping surfaces. You have to make sure the water pressure and flow are low enough to prevent washing away the surface. The water needs to land gently on the surface. We set up a mechanical system of pipes and hoses stretching across or around large slabs of fresh concrete. For smaller slabs, we can use a gentle garden sprinkler. We can even set up the system to keep the concrete surface wet all the time. The advantage of this method is that it won't change the surface coloring, leaving it clean and ready for painting or other coatings. However, there are some downsides. It can be tricky to maintain the equipment and get enough water for the job. Also, if the wind starts blowing, the fog or light spray might miss the target. Another drawback is that any other work happening on the slab has to stop during curing because it's constantly being wetted. Damp coverings are mighty helpful in the curing process as they keep water close to both flat and upright surfaces. The materials used can range from burlap, cotton rugs, and mats to other absorbent stuff. It's important that the materials used are clean and don't have anything that could stain the concrete. Before or right after placing the covering, it needs to be thoroughly soaked and kept wet throughout the entire curing period. At times, burlap coverings are coated with plastic to reflect light and heat. Cotton mats and rugs can hold more water than burlap, but they take longer to dry. To make sure the covering stays wet, you can use sprinklers or foggers along with the wet coverings. If the covering dries out before the curing process is finished, it will draw moisture from the concrete itself. Using clean fabrics helps prevent staining from foreign substances. Burlap and similar materials are fairly cheap and can be reused. The wetting systems can malfunction, so it's crucial to monitor them closely to ensure proper curing. A water-resistant layer laid on top of the concrete surface will hold moisture by preventing it from evaporating since the moisture can't pass through the material. The main benefits of these water-resistant layers are that they allow access to the slab during curing and don't require continuous moisture supply. The traditional water-resistant paper consists of 2 layers of torn craft paper, reinforced and bonded with asphalt. It's resistant to vapor, sturdy, doesn't cause stains, and is tear-resistant, although it's not used as much nowadays. Another type of material used is made from non-woven fabrics coated with a white polyethylene film. Both materials trap and retain water in the concrete below without staining like regular plastic sheets. Before placing the water-resistant layer, the concrete needs to be watered down. Then, the layer is unrolled smoothly and without wrinkles across the entire slab. The layer must cover all exposed surfaces, sides, and edges of the slab. The joints where the water-resistant layer overlaps typically need to be sealed with non-staining glues or tapes. The edges of the layer should reach down to the ground and be covered with sand or wood to seal in the moisture. The material must be weighted down at regular intervals to ensure it remains in contact with the surface. Another advantage of a water-resistant layer is that it leaves the slab clean and ready for bonding. Since it wrinkles less than plastic, it's less likely to cause discoloration to the concrete. Plain old plastic sheeting also works as a vapor retarder. It helps with the curing process by putting a stop to evaporation from the exposed concrete surfaces. The plastic film should be at least 4/1000ths of an inch thick. People usually sell and label plastic sheeting based on its thickness in mils. 1 mil is the same as 1/1000th of an inch. So, 4/1000ths of an inch is the same as 4 mils. That said, thicker sheeting tends to be more durable and can likely be reused more times. You can find the sheeting in clear, black, or white. Black film absorbs heat during winter, while white film reflects heat during the summer. Before laying the plastic, make sure the concrete surface is wetted down. Then, Unroll the sheeting flat and overlap it by at least 6 inches. It's important to secure the plastic so that it maintains consistent contact with the concrete surface. If you leave wrinkles and bubbles during installation or don't address them properly, you can bet they'll cause spotting and discoloration on the surface. It's crucial to get rid of any wrinkles as you roll out the plastic sheeting used for curing. The sheeting must also be carefully wrapped around the exposed surfaces and sealed to the ground using lumber or soil. The advantages of plastic sheeting include being cost-effective and easy to put in place. Unless you're dealing with high winds, it can be reused, especially if you go for heavier material. However, its downside is that it wrinkles easily, leading to discoloration. Plastic isn't recommended when you're working with colored concrete or when the final appearance of the surface matters. It can also tear easily if there's traffic over the fresh slab. It's best to use material heavier than 4 mils for longer-lasting service. There are liquid curing compounds that form a film on the concrete surface, and they contain waxes, natural and synthetic resins, and sometimes solvents. You can apply these compounds using a brush, roller mops, or pressurized spray. They are applied on damp concrete immediately after final finishing. When spraying the material, all adjacent surfaces need to be covered to protect them from overspray. Insulating blankets aid curing by holding in both heat and moisture. Manufactured blankets are the best approach, but field-fabricated methods are also an option. These blankets are wrapped around forms containing fresh concrete to retain the heat of hydration and protect them from the cold. Although the blankets are primarily used on slabs, they can also be adapted to other placements. Their flexibility makes it easy to cover both regular and irregular horizontal and vertical forms. Concrete cures best when it has the right amount of moisture and temperature, so fresh concrete needs to be protected from the local environment. This includes extreme weather conditions. The following activities are recommended to support proper curing in hot weather. Thoroughly moisten the subgrade prior to placement so it will not absorb water from the concrete. However, there should not be any standing water on the subgrade when the concrete is placed. Monitor fresh concrete temperatures for undesirable temperature changes. Wet the forms in advance to cool and keep them moist. Shade them from the sun with reflective covers. Cool the mix by using ice to replace a portion of the mixed water. The weight of the ice used should be the same as the weight of the water for which it is substituted. You can even add liquid nitrogen into the mixing water to turn it to slush. You can use a retarding admixture to slow the set and lengthen curing time. Use supplementary cementitious materials to reduce the heat of hydration. Place the concrete late in the day, ideally after the sun sets. Use continuous fogging to keep the surface wet. Use white pigmented membrane-forming compounds, plastic sheeting, or wet burlap coverings to reflect heat and hold in water. Taper off the curing process gradually so the concrete will not be shocked by sudden exposure to a dry, hot environment. Concrete sets very slowly at low temperatures. The following activities are recommended for curing in cold weather. Avoid placing concrete during extremely cold weather. Use insulating blankets overnight to protect the subgrade. Heat mix water and added materials. Use an accelerating admixture to speed hydration and shorten finishing time. Do not place concrete on a frozen subgrade. Use insulating blankets overnight to protect or thaw the subgrade before placing concrete. Heat form surfaces as well as reinforcement. Monitor freshly placed concrete for an undesirable drop in temperature. Wrap and seal insulating blankets around forms as well as the slab surface. Use black pigmented membrane-forming compounds, plastic sheeting, or craft paper to absorb solar heat and retain moisture. A temporary housing can be built around the placement site from wood or prefab panels. The housing needs to be weather-tight and may require heating equipment to maintain the desired temperature range for curing. When heat is applied, the hot air can cause concrete shrinkage problems as it draws moisture from the concrete surface. To avoid this, fogging may be necessary when heated housing is used. Space heaters for temporary housing must be properly vented outdoors. Carbon monoxide from unvented space heaters is a serious health hazard to workers, and the carbon dioxide from an unvented heater will bond with wet concrete, leading to carbonation of the surface. Wind affects curing by increasing the evaporation of water. When a strong wind is present, water must be added to the surface more frequently. Wind also shifts water from sprayers, sprinklers, and foggers away from the target area, potentially allowing specific areas to dry out. Winds are typically at their worst in the late morning through the afternoon due to the natural heating effect of the sun. Work can be started late in the afternoon to take advantage of a reduced wind speed at sunset. Rain creates problems by adding moisture in an uncontrolled manner. If the rain comes after floating, then it is less of a problem and can often be treated as excess bleed water to be removed before other finishing activities can begin. Once finishing is complete and the curing process is underway, rain is less of a concern unless it is severe in terms of duration and intensity. Burlap and other materials placed on the surface for wet curing can help protect the concrete from the impact of the raindrops and the erosion they can cause. Loads driven over new slabs can damage or ruin the surface completely. The best protection is to keep all traffic off the slab for at least the first 7 days, but this is rarely possible in the construction environment. When activity must be allowed, it should start with foot traffic, small equipment, and light material loads. Craft paper, plywood, or similar materials can be used to provide light traffic paths over a slab. Heavy traffic can overload the concrete, especially at the edges of slabs, and cause cracks and breaks. Use common sense to protect uncured concrete from heavy loads, especially around the perimeter. Every operation needs a hazard analysis during a team huddle before we start. Thanks for watching, and remember, you are the key to our company's success and safety. See you out there on site.